The next section of the proposal mentions the project lifecycle based on CRISP-ML. This reflects on the section 4 of the course. The first phase in CRISP-MLQ is business understanding, that includes business requirements, product business value, and success criteria. Business requirements. Develop a machine learning-based solution to automate the property listing process for Orpi. The solution must automatically categorize property photos into the correct category. The system must email staff and alert if the probability of incorrect categorization is above or equal to 10%. The system should provide a user interface for staff to monitor and intervene in case of errors or poor predictions. The solution should achieve the photo categorization of each property in less than 40 seconds. Product business value. Reduce operational cost by eliminating the need for manual property listing. Improve time to website for each property, increasing customer satisfaction and positively impacting the advertising campaign's effectiveness. Enhance staff retention by eliminating tedious manual jobs, improving job satisfaction, and reducing staff turnover. Minimize HR costs associated with hiring, training, and onboarding new staff. Protect the company's reputation by addressing negative reviews from employees' dissatisfaction with manual tasks. Success criteria. Achieve accurate property photo categorization. Reduce property listing time to less than 40 seconds per property. Maintain a probability of incorrect photo recognition below 10%. Reduce operational costs associated with manual property listing. Improve customer satisfaction and reputation metrics by end of quarter 2 of 2024. Reduce staff turnover and HR costs by 20% by the end of quarter 2 of 2024. Data understanding phase. Data requirements. Collect property details including attributes such as property type, location, and other relevant information. Gather a large dataset of property photos with their associated property details. The dataset should represent the diversity of properties that are usually listed by Orpi. Catalog, profile, and validation. Create a comprehensive catalog of property details attributes including data types and expected values. Profile the collected data to identify any data quality issues such as missing values, inconsistencies, or outliers. Validate the data by cross-checking existing property listings to ensure accuracy and completeness. The third phase is data engineering, which includes data selection, data cleaning, and data construction. In data selection part, select the relevant property details, attributes, and photos from the collected data set for training and testing the machine learning model. Data cleaning. Handle missing and blurry photos and the outliers, for example, photos of pets and children. Perform data cleaning and data normalization. For example, if the category used as an attribute is a staircase, then that record must be attributed to living room or be deleted. Staircase is not an expected predicted value. Data construction. Create a mapping table for a photo to its category, for example, to bedroom. Pre-process and augment the property photo dataset. For example, convert photos to a hash value constructed based on the pixel values in the image file. ML model engineering phase. ML model engineering phase includes model selection, model training, and model registration. Model selection. Evaluate various machine learning algorithms suitable for property categorization and photo location determination tasks. Consider decision trees, random forests, and deep learning models such as convolutional neural networks or CNNs. Select models based on their performance metrics, interpretability, and computational requirements. Model training. Train the selected models using the pre-processed property details and photos dataset. Optimize the model hyperparameters using techniques like cross-validation. Split the dataset into training, validation, and test sets for model evaluation. Given the large dataset of photos in hand, use 80%, 20%, and 20% distribution. 80% is for training the model, 20% is for evaluating the model, and 20% is for the testing the model. Model registration. Save the trained model and associated metadata for future reference and deployment. Register the model using MLflow, an industry standard machine learning lifecycle management tool. Establish version control and tracking mechanisms for model updates and improvements. Create a GitHub organization for Orpi and store all the code and model details in the relevant repositories. Provide access to Orpi on those repositories for transparency. The next phase is machine learning model evaluation and deployment, which includes model evaluation and model deployment. In model evaluation, evaluate the trained models using appropriate evaluation metrics such as accuracy, precision, and recall. Use F1 score if the photo distribution is not balanced amongst various property types and locations. Fine-tune the models if necessary to improve their performance. Record the parameters used, model output, and other relevant information at each stage. Model deployment. Deploy the model as a prediction service in Amazon Web Services. Build APIs that expose the prediction service to other microservices. Build a trigger that initiates the prediction process each time a new photo is uploaded to the photo storage. Build a user interface to view the results of the predictions and enable staff to intervene and correct inaccurate predictions.